Okay, now that we went through use state, use callback, and use memo. So we went through use callback, use memo, and memo. We're gonna talk a little bit how React functions under the hood. We already mentioned that React components update every time the state changes, the props change, or the parent re-renders, unless that component is wrapped in memo, i.e. if it is a pure component, then it's just if the props change or if the state changes. What I want to talk about just briefly is what does updating actually mean? Does it mean that React, every time a component needs to update, runs the React code and changes right away in the browser? I mean, judging by my tone, you can probably say that's not how it works, right? So what React has is a virtual DOM. What's a virtual DOM? So let me just go for a moment back. Virtual DOM is basically this. It's React's representation of the DOM with all of its components. And there might be more things going around under the hood, but in essence, this is how React sees your code. This is called the virtual DOM, and this right here in Elements is the actual DOM. DOM basically means the HTML that gets generated in the browser, and it's short for document object model. Document because HTML is a document, but they're all objects, altogether it's a model. That's it. So I think in our first lecture, what I mentioned is back in the old days, in the older JavaScript libraries, what we did is we wrote JavaScript that would change their elements directly here, directly in the HTML, in the actual DOM. For the sake of maintainability and also to make things faster, we don't do this, because manipulating the actual DOM, as it is right here, is akin to actually writing over a file. You need to read the file, write in the file, go back in there, and then the browser needs to basically parse through all of that again and stuff like that. It doesn't really do all of that. It's smarter than that. Browsers today are a bit smarter than that, but it's still a bit slow. And what React does is it creates this in memory. So it keeps a tree-like structure in memory, and from time to time, it will update the actual DOM. It will use this to update the actual DOM. Maybe update is not the right word for that in React terms. In React, we say commit. So the changes that were made to the virtual DOM get committed to the actual DOM. And it's done basically all together. What this enables React to do is see which is the minimal amount of update it needs to do, and just do a diff between the old DOM and the new DOM and do that. And along with that, in cases you're getting a lot of updates, a lot of state changes rapidly, that auto clicker I mentioned previously, maybe React will just potentially update two things in its own memory, but it won't have time to commit that to the DOM, and that won't be a problem because the user wouldn't be able to see that anyway. And it's gonna wait and see what it needs to actually commit to the actual DOM and what the browser actually needs to draw. In practice, every round of updates gets committed, but there's this buffer zone in between that can be utilized to improve performance. This is not something you do as a React developer. You actually just optimize this, the virtual DOM. And so all of the updates that need to happen here, just as we did right now. And you let React do what React does and act as an engine. So that whole metaphor as the engine for game development. You let React act as an engine for web development and draw your actual application from this virtual DOM and use your code to manipulate this virtual DOM. There are, of course, exceptions where you might need to go here and write specific code that isn't linked to React, but generally that's more of an exception for specific features than a rule for something you need to do. The virtual DOM is React's in-memory representation of the actual DOM that React uses to track changes, track updates, and basically to function more performantly. This is a cute illustration of how it works. It's taken from the React.dev documentation that I've talked about 2 lectures ago. And so this is basically what happens every time. An event gets triggered, so the click. The component renders, so we get the new state and the component updates, and it renders and it shows up in the virtual DOM. Then React takes that virtual DOM and commits it to the actual one. After that, the browser looks at the DOM and the browser draws the stuff on the screen. That's it.